Welcome to doassignment-ca. Here is the problem. A package is dropped from an elevator at a height of 100 feet above the ground. The elevator maintains a constant upward speed of 4 feet per second. The package is released with the same upward speed as the elevator. Assume gravitational acceleration is 32 feet per second squared. First, determine the height of the elevator from the ground at the instant the package hits the ground. Second, draw the velocity time curve for the package during its motion. Now let us work through the solution step by step. Let's set up a coordinate system with the origin at ground level and upward as positive. When the package is released, it starts at 100 feet above the ground with an initial upward velocity of 4 feet per second. Gravity causes a downward acceleration of 32 feet per second squared. The position equation for an object under constant acceleration is y equals y naught plus v naught t plus 1/2 at squared. Substituting our values, y of t equals 100 plus 4t minus 16t squared. Setting y of t equal to 0 gives 100 plus 4t minus 16t squared equals 0. Rearranging and dividing both sides by 4 yields 4t squared minus t minus 25 equals 0. Applying the quadratic formula with a equals 4, b equals -1, and c equals -25 gives t equals 1 plus or minus the square root of 1 plus 400, all divided by 8, which simplifies to 1 plus or minus the square root of 401, all divided by 8. Taking the positive root, the square root of 401 is approximately 20.025, so t equals 21.025 divided by 8, which is approximately 2.628 seconds. The elevator continues moving upward at 4 feet per second. Its height is given by 100 plus 4t. At t equals 2.628 seconds, the elevator height is 100 plus 4 times 2.628, which equals approximately 110.51 feet. The velocity decreases linearly with time according to v equals 4 minus 32t. At t equals 0, velocity is 4 feet per second upward. The velocity reaches 0 at t equals 0.125 seconds when the package reaches maximum height. At t equals 2.628 seconds, the velocity is approximately negative 80.1 feet per second, meaning the package is moving downward. The velocity time graph is a straight line with a slope of negative 32 feet per second squared. It starts at the point 0.4, crosses the time axis at t equals 0.125 seconds, and ends at approximately 2.628, negative 80.1. The constant negative slope reflects the uninterrupted downward acceleration due to gravity. The elevator is at a height of approximately 110.51 feet when the package hits the ground. The velocity time curve is the straight line v equals 4 minus 32t, beginning at 4 feet per second, passing through 0 at t equals 0.125 seconds, and reaching approximately negative 80.1 feet per second when the package strikes the ground. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.